Find the equation of an exponential function given the initial value and a point. So let's first recall an exponential function. So we know that an exponential function will look something like f of x equals a times b to the x, where a is the initial value. What are we starting with? And b is either the growth or the decay factor. Now, with b being the growth or decay factor, it still must be greater than 0. But it cannot be 1. If b is 1, we are neither growing nor decaying. We are just being, and that's not what we're looking for. So, what are the steps to write the function when we are given the initial value? So, first things first, that initial value is a, so we'll substitute it in. Then we're going to take our second point, right, our xy point, and we're going to plug that into the equation. So we'll have a, we'll have x, and we'll have y, leaving us, because remember, this is our function. So if we know y and x and a, we can solve for b. Once we solve for b, then we plug back in our a and b, and we have ourselves an exponential function. Sounds easy enough. Let's go ahead and make some magic happen here. So we will find an exponential function through the points 0, 6, and 2, 54. Now from this, how do I know my initial function, or my initial point, or my initial value? Well, if we think about the equation, okay, so let's just look at this point here, 0, 6. 6 equals a times b to the 0 power. Well, what is anything to the 0 power? That's just 1. So this is a times 1 equals 6, so a equals 6. So your initial value happens when x equals 0. So if x equals 0, then a is the same as the y value, which in this case is 6. So to make a long story short there, we know that a is 6, and then we can use our points 2 and 54. So again, let's remember our a times b to the x. And if you struggle remembering formulas, I would recommend writing it down just like I did here. Then, so you write down the f of x equals a times b to the x. Now plug in what you know. I know f of x is equal to y, so that's 54. Equals my a value, well, that's 6, times b raised to the x, x is 2. Now I need to solve for b. So the first thing I'm going to do is divide both sides by 6 to isolate the variable. So that isolates b squared. So b squared equals 9. And when I solve both sides, I do that by taking the square root. So b is going to be 3, or b is going to be negative 3. But go back to what we talked about a few bits ago, and that is b must be positive. Therefore, when I get over here, I can say, nope, b is not allowed to be a negative value, and therefore my value of b is 3. So my function would simply be f of x equals 6 times 3 to the x. And there is the exponential function. Let's do one more. Find an exponential function that passes through the points 0, negative 3, and 1, negative 12. All right, we found x is 0, so that means my a value is negative 3. I have x, I have y. So once again, I'm going to start with my basic function, f of x equals a times b to the x. Now I can go through and I can plug in what I know. I know that f of x is the same as y, which is negative 12. My a value is negative 3 times b to the x, x is 1. To isolate my b value, I divide both sides by negative 3, and I end up with b to the first, which is just b, equals a positive 4. So I know a, I know b, so I can write my function f of x equals a, negative 3, times b, which is 4, raised to the x. So f of x equals negative 3 times 4 to the x. You might also want to just put that 4 in parentheses. Mathematically, they're equivalent, but sometimes using parentheses instead of that multiplication dot, sometimes it's just easier to like differentiate and see things. But either way, it works.